Testing sound. Oh, that worked. Good. Always a good idea to test first. I need to figure out how to get item in there, which means that I need a version of OBS that's perhaps not a distro version and not a yeah. So today I'm going to go over a little bit of something that I've been fiddling with. Then we'll go to the compiler project. Well, let's see here. Hi there, Mr. Elfman, or Mr. Sir Elfman. I have a different ambitious project I'm thinking of embarking on, and I've been doing some research about it. Part of that research is involved getting Chat GPT, or rather Codex, to generate me a project skeleton. And it's kind of a restart on a project that I was working on a long time ago a few years ago, called POSIX PP. And POSIX PP would greatly benefit from C++ modules. And I've been kind of waiting for C++ module support to sort of reach a place where I could actually just go forward and make it a module first project, like one that only used C++ modules. The goal of the thing is to actually completely replace the underlying infrastructure for C++, like no more libc, that level of replace. And also to radically change the C++ standard library, like mostly keep what it currently does. I think that the library designers have made a number of very good decisions, but toss away a lot of the things that are like legacy things that aren't really needed anymore, that are there kind of to maintain backward compatibility with C, or because they decided iterators were a great idea and then realized later that ranges, in fact, were probably a much better idea, stuff like that. Um, For that, trying to use CMake as your build system is a bad idea. So that's, I still haven't looked at your language, Mr. Elfman. I'm sorry. I need to allocate some time to do that. Maybe today after I get done with a thing that I intend to do that I have to get done, or that I do later, that finishes at 7:30 p.m. So maybe today at 7:30 p.m. my time. Anyway, how are you doing, Mr. Elfman? What do you think of my my new project? Um, anyway, I'm going to use Ninja for the build system, partly because I think Make is pretty long on the tooth, and one of the things that Make is really bad at handling is it's really bad at allowing the compiler to tell you anything about what the dependencies are while it's compiling. And apparently this is a thing that Ninja was designed to explicitly fix, as well as fix things like your build depends on the command line arguments to the compiler, clearly, stuff like that. And so this means I actually have to understand Ninja. And so I got ChatGPT, or, well, as I said, Codex, to write me up a bunch of Ninja stuff. First, with the idea that I was going to do module compiles. And C++ modules have grown some, the compiler has grown some very interesting options with regards to how to find modules that ChatGPT didn't incorporate into the build file. And I'm thinking about running some experiments on. But also, I really should sit down and understand this fully. Like, how does this actually work? How would I accomplish the kind of dependency stuff that I want to accomplish? Things like that. And also, too, there's going to be, well, I'm trying to replace libc and libstdc++. I think there's a place for, as this thing is coming up, to have sort of tests of subsets of its functionality using libc, or using like catch2, like a standard C++ thing. Eventually, it should achieve a state where once you bootstrap it, you can test it without any reference to libstandard C++ or libc. But until that point is reached, I want to be able to test things. So it's kind of like a couple of alternate build paths to consider. That was actually another place where I kind of got stuck last time. Was there's in fact a fair amount to the runtime environment of C and C++, especially C++, that most people don't know about. And one of those pieces is exception handling. There's a bunch of runtime support for exception handling in C++, and it's non-trivial, and I need to replicate it. There was a really great presentation at CPPCon 2025 about exactly how the C++ exception handling mechanism worked. And there are a lot of people who think exceptions are terrible. We shouldn't be using them. I think that it's a lot more nuanced than that. And there are really good places to use exceptions and really good places to not use exceptions, and that people should in general have the choice. And so I think that's the other thing, is I want to redesign this entire API with the idea that you have something like STD expected for all error returns. Yeah, no, exceptions shouldn't be flow control, although Python does that. Like, oh, you want to end a loop? Well, throw stop iteration. Yeah, no. uh, that's kind of ugly. But Python actually has baked into the language some aspects of using exceptions for flow control. But yes, I agree with you. Exceptions are poor flow control. Well, that's also true. Python is just going to be slow, and that's that. Um, so anyway, what do you think, Sir Elfman, of my idea for a project? I did make a fair amount of progress on it. I actually do have a POSIX PP that where I compiled a hello world in C++ that compiled down to, once you stripped it, it was something like less than a K in size. It and you look at the code. In fact, I think I might even have it here. Uh, and then if we look here, I think uh, oh, foo is not it. What was it? I think actually it ended up in build. No, this one wasn't it. Oh, it's going to take me a while to find it. But I did have a version. Yeah. Notice how this version of main here uh, doesn't call anything, doesn't call any functions. Just the syscalls appear directly in line. I have I looked at your web demo and saw it's a web demo, and I saved the link someplace. I haven't looked at it since. I mentioned earlier that I apologized to you about that and promised to look at it at 7:30 p.m. today because I won't have time to look at it until 7:30 p.m. today. Um, it looked nifty. It was a well-designed web demo. It looked pretty. I can say that much. And there is clearly a programming language I hadn't seen before involved. I can also tell you that. Um, but anyway, uh, this is the hello world.cpp, right? And then the resulting object file. And as you can see, it makes no library calls whatsoever. Everything is just translated directly to a system call, including the exit. The exit is also a system call. Um, it also requires its own startup function that calls main and sets up the call stack. And I do have a version that did that, but it's been a long while, and I'd have to spend a bunch of time trying to recreate it. But I was quite pleased by being able to create a hello world where this is basically the entire executable is this assembly. That's all that's needed. That's it. Um, Notice how this assembly makes no library calls whatsoever. Well, okay, maybe here. Actually, no, this one is just jumping to the return. Yeah, this no library calls whatsoever. So, uh, yeah, which is, in my opinion, how system calls should work. They should be inlined. There's no good reason. And one of the reasons to have them inline is then you can be much more detailed about exactly what memory is going to be. No dynamic linking. Nope. I do intend to make the library dynamically linkable once it's done, but uh, this I didn't don't do it any for this hello world example. No dynamic linking. No. um, but it doesn't have to use any dynamic linking because, like all of these functions that are being called, Like these are all inline stuff. Like these are templates and inline stuff, and they are actually pretty darn simple. Um, this is this is it. Um, and this call to read here uh, actually translates into an inline function that just uh, double that this inline function that just directly makes the syscall. Um, as I said, I think that this is generally how things should work. Partly because, as I said, you can in fact be much more detailed about telling the compiler what memory the syscall is going to clobber. You can say, oh yes, this syscall instruction here, you should think of this memory and that memory as being clobbered, and also too, it takes this memory as input, so this memory needs to reflect reality, right? Yeah, and the other thing it enables it to do is more efficient register allocation, because right now, when a syscall is made, there's a whole lot of register shuffling as things get moved into the appropriate registers before the syscall is made. But if the syscall is inline, well, the compiler knows exactly what registers the syscall parameters need to be in before it ever executes the instructions. And so it can just arrange all of the surrounding assembly so that the values that are needed just magically appear in those appropriate registers as a result of computation, instead of having to be shuffled in there in a few instructions before the syscall is executed. Um, so yeah, there's a whole lot of reasons why I kind of like this way of doing things. Um, and I think that it has a lot of potential. Now, it's not like syscalls are like the hot path. Anytime you're making a syscall, that's a huge amount of overhead, and optimizing for making the syscall really fast, it's not necessarily the best optimization to do. But it's not nothing, especially if you can be clear. Like right now, syscalls are treated as, well, all of memory might have been fiddled in this syscall, and all of memory needs to reflect reality before this syscall, and that's not true. And that's actually opportunity for some really huge optimizations. Of I don't have to flush these values to memory because the syscall doesn't even use them. Um, so I and actually, the bigger optimizations will probably be in the other end of like, oh yes, I can assume that all memory contents are the same before and after the syscall, except for these ones. These ones will change, and I need to do something about that. So yeah, I think that's the biggest optimization opportunity. But the other thing it enables me to do is, if you look at hello world.c here, um, I'm checking here if result has error. Right? The result that I get back from read is actually a result that is very clear about errors. And I can, there's ways to get the error value out of this as well, although right here I basically ignore it. Um, but uh, yeah, I, yep, I think that error return should be, you shouldn't have to go referring to errno to find out what happened. It should just be part of the error, the result. And also too, this, if you try to use the result's value without checking to find out if it has an error, like if you try to use the result as a value when it is an error, an exception is thrown. Um, and so it makes it impossible to skip out on your error handling, um, which is something else I like. Oftentimes, that's actually the exact error handling I want. I'm expecting all of these syscalls to succeed. I don't want to deal with their failure. That's perfectly acceptable for the program to terminate on failure. It would just be nice to know why. And this gives me that. Yeah, I know, right? But all this stuff is all about the abstractions, right? And so that's why it compiles down to such a tiny amount of assembly. It's actually kind of interesting. C++ has a tendency to be very verbose with uh, with in comparison to the assembly that's produced if you're careful about how you write your C++. So anyway, that's this project. So let's get back to the parser that I wrote. And I have a bunch of sample programs here. So, and I got the sample programs to work. My favorite one here is this one. Decided that TY, actually I should change it to TIL for today I learned, or some variant of toy language. Um, but like, right, you actually run it. There is the answer. And then it prints out all this stuff. Some parts of this are wrong. Like, I don't know why we're getting this program structure out of it. I think that all of these are a little broken. Yeah, const-eval and const-expr are really powerful. One thing to do with this language that I wrote is to, in fact, make the AST generator fully const-eval. That would be a thing to do. Um, that would be or fully const-expr, like being able to parse a program written in this language in a const-expr context and get a const-expr AST out of it. I don't know that that's something I want to do, but that would be a project to embark on with this, and probably feasible. Um, what I'm thinking I'm going to do next after this is there's a couple of different directions I could go. I could figure out why is this so messy and why does it seem broken. I'm not completely sure that all the parentheses match up the way they're supposed to. You know, I actually have an Emacs window, so I can go find out. Let's go to my Emacs window and see. I pulled up the Emacs window because I wanted the info pages for the C compiler. But let's see here. Do the parentheses match? Indeed, the parentheses match. Okay. Well, that's nice to know. And that defund there, that matches exactly where it should match. In fact, I can probably re-indent everything. That would help. Why the double progn here? I do not know why all the if clauses have double progns. I don't know if you know Lisp very much, Mr. Elfman or Sir Elfman. But progn is basically its way of here's a whole series of things to evaluate, and no, that's not what I wanted at all. There you go. Okay. Progn is its way of saying here's a bunch of statements that need to be executed in order, and the value of progn here is the value being yeah. This is an end to the if, and leave an end to that progn. And there's the else part. So why does every clause, I'm curious as to why this happens. I would have to go through the recursion to find out what the heck is going on here. But like, yeah, this is just weird and annoying that every single branch of the if statement here has a double prog n. Like, what's going on? So have you heard about C++ 26's reflection features? I mean, templates, you already can kind of do that, right? You can kind of already insert code at compile time using templates. Um, the text in this might be kind of small. Oh yes, I have to move this over because it, and I should check, find out exactly where that boundary is. Oh, there we go. A little bit of it was getting cut off there. Yep. So the edge, the border is interesting. I wonder why that border exists. I bet there's a border over here too. Yep, there is a border over here. So no, you cannot make malloc const eval. Now the new is const eval in a very specific kind of way. Uh, as long as your program leaks no memory whatsoever, as long as your const eval, the thing that's being constantly const evaluated is has no memory leaks whatsoever, you can use new and delete inside of const eval functions nowadays. So it's kind of like new and kind of like malloc, but no, you can't actually use malloc. You have to use new and delete. Um, it's just that everything has to be cleaned up at the end. You can't have anything left over. Yep, means that you can actually use vectors in const eval functions nowadays. I believe that was added in C++ 23. Try it out with your local compiler. Fedora has a nice copper package, and that copper package that copper package has GCC latest in it, which is basically a trunk build of the GCC trunk. But on the other hand, the C++ 23 support in the version of the GCC that shipped with Fedora 41 is pretty good. It's pretty complete. And I imagine later versions of Fedora are even better. That's what I use on my desktop right now. I'm actually thinking of switching to CachyOS, but that's a huge jump, and Arch is complicated to install. And that's what CachyOS is, basically a form of Arch. Um, but so why am I getting the double progends here? I think maybe that is the mystery that I will solve for now. Why in the if statement do I get double progends for the if and else clauses? In the in here, we want not infix stringizer. I don't care about that right now. That's just something that has to be fixed at some point, though, because I have some places in there where I basically just punt. But the prefix stringizer, this is the one I like because it preserves structure. So if statement. Oh, that's why. Hmm. So what happens if I just do this? Okay. No, that works out right. So technically, I might be able to get away with not having this part right here. Oh, Ness, this is not Emacs. I might be able to get away with just doing this and then skipping out on this part. And then here for the result part, just do this. Yes. And then do that. Technically, I don't think this needs to be here either. Um, all right. Have a good evening, Sir Elfman. Thanks for showing up. I'll look at your thing later today, this evening. No, I don't want all C test. I want specifically Lexer test. That's what I want to build. That should be just perfectly acceptable. Yep, that worked out well too. If I do that, I get that, which that's what I should be getting out of it. That's right. Okay. Ah, no, that's correct too. Actually, yeah, that is what I want. Mhm. Yep, that's what I want. Right. Actually, I think it needs a few more spaces here. Uh, nah, I think this is good. It doesn't need any more. Well, okay. It needs 4 spaces. That's actually something that this prefix stringer also should start managing is keeping track of the indent levels and doing the best job it can there. Oh, I know. I remember what needed to be added. Forward declarations. Um, well, we should have this here. Actually, I just realized there is something important I forgot to do today, and I really need to attend to it now before I actually forget. Uh, so I will leave you with code to stare at, and I will be audible. As I go attend to the thing that I need to attend to. Let's see here. Right. That taken care of. I really need to figure out why the sides are getting chopped off here. Um, but I'm not going to fiddle with that right now. What I am going to fiddle with is this will break a lot of tests. Um, okay. Yep. This is correct. And this other one, yeah. So we will fix it to be the new string. And that was from this extension. No program here. like this. And then this is only like that. Yep. Exactly. That should cause that particular error to go away. But there's probably another error with the while loop. Okay. What is wrong here? So that's 7. That's 7. Lots of extra spaces there. What didn't work about this? What's different? Ah, yes. And that X should never have been in parentheses in the first place. The test as it was an error. Or, well, the output as it was was in error technically, kinda. I mean, this is textual output. I would like it to be kind of a valid program inside of a pseudo-Lisp-ish kind of language, is what I would like it to be. And it wasn't, in fact, a valid program in a pseudo-Lisp-ish kind of program. Indeed. Oh, and also, too, this should probably be like that. Yep, if 1. And that's the problem. I didn't do that. Okay. So then there's one more one that didn't work here. And so let's go here. If 0, no progan. 22, no progan. 24, like that. And also one less of these guys. Takes too long to compile and run this thing. All right. So it doesn't like this one now. Okay. This is an actual problem in my parser.cpp in this. This is probably not a problem. Is this a problem? If yes, kind of. So this ends the if, and this ends the progen. So this one is correct. This one is not correct. So after the 42, what the heck? It's the original. Oh, there's supposed to be an else 24, and there isn't. There isn't an else 24. Something is getting parsed incorrectly here. Really? Oh, no, not here. Okay. This one is incorrect. If 142, then there's no else. Yeah. And so this does not appear. No. If one, yeah, this one is not necessary. All right. This one here, this one should not be there. That is correct. There should be no, yep. Oh, this takes too long. A reason to use modules. There we go. Sorry, not postfix. My prompt string isn't working correctly. It should be telling me that I'm on a bookmark or something, but it isn't. It's something else to look into at some point in time. Probably my HD prompt extension is too old. It's out of date. It needs to be updated or something. Anyway. Next, an actual substantive change that I realized needed to be made a while ago. The mutually recursive function example in not while test, but func test. This example shouldn't fail. It should work. There are a few other examples in here that fail. I should fix error handling at some point in time too, but that's not a priority. They're a priority. The whole point of toiling is not to handle errors. But this code should work, and it doesn't work. And I would like to fix it so it does work. So first thing we have to do, where do I have? Nope, that's fine. So the place that I need to alter is here. I'm just going to go bloop, like that. Sound effects. The computer isn't making any, make your own. So I need to rename func declaration to func definition. And then have be exactly the same, except this. And then there, like that. And then, oh, I forgot to add something to this. So this comment was an error. I don't have any checking on the comment. It's one of the problems with comments is there's no test checking the comment to make sure it aligns with reality. And I forgot to put something in here, which was there. All expression statement is too big. first, I should first copy okay. Now we edit this again. Oh, come on. Oops is not necessary. And okay, so I need to get rid of 7 characters here. First of all, we're going to try putting this in these instead. Okay, that's even worse. Oh, that's because of this backslash. Okay, 72 need to strip out 5 characters. There we go. Yep. Now, all right. Now what we need to do here, we need to do a refactor, rename. All right, that should solve that problem. Let's see if all the tests still run. And indeed, all the tests do still run. Okay. Next up is we should make this parse func definition. I think we're going to fold in declaration and definition into this and maybe rename it again. Anyway. Now, actually, I'm kind of curious as to what it will decide that I'm doing here. Yeah, it missed Y. All right. All right. Just sometimes checking in what the AI thinks the proper changelog comment is, as again, it's wrong. Too verbose, doesn't actually understand the intent. All right. So making this work, the thing is if you look here, definition and declaration are almost identical. The only difference is whether there's a semicolon or a sequence of statements. Um, so that's a thing to think about because it probably should be the same program or same code that does most of this work. Maybe I should modify the pseudo BNF to split this out in the way that will probably occur in the code, so that most of the work, in fact, is combined, and then only Roger and or sorry, I don't know what I was thinking. My mind wandered for a bit. Most of the code is the same, and then it checks the semicolon or brace thing and takes one branch or the other to decide whether it's a declaration or a definition. Um, so, yes. I don't know that I want to embark on that change right now. I think that I shall embark on that change later. Um, so that'll happen next time. Again, I hope to not been very good about keeping my schedule, but I really would like to do this Tuesday at 5 p.m. And I'll probably make that one Tuesday at 5 p.m. East 5 p.m. 17 o'clock 1700 hours Pacific Standard Time, Seattle time or LA time. So that's what I hope to do. Yeah, yeah. All right, so that's it for this evening. Next evening is going to be implementing forward declarations, and then basically making the mutually recursive function example work correctly. So until then, have a good day.